Let's discuss the question from theory of machine. Okay, so we are asked to find out the natural frequency of this system. You have a spring and a mass, and then you have the other end of the wire of the cable is goes around the pulley, and then you have a spring connected. Well, these kind of problems, remember that what is said is that the pulley is light, so pulley doesn't have any rotational inertia. Okay, because it's light, so it doesn't have any mass. Even though it rotates, the rotational inertia can be neglected. So these kind of a problem, you have to always see what is, you have to always convert it into a single spring mass system. Okay, something like this. I mean, something like this you need to convert, because for this you know, right? This you know the natural frequency. So how do I convert this? Okay, so first displace, when you displace a mass by delta and look at the force that is acting. When you displace a mass by delta, the downward spring will be in compression, and that provides an upward force, because when you try to compress a spring always tries to regain its equilibrium position. So if you try to compress it, it will try to push away, and that force will be k delta. And when you try to put this delta down, remember that this is moving delta down, so this will be moving delta up, so this will be in tension, right? This will be in tension, and when a spring is in tension, it will try to pull back, so there will be a force that is acting like this, and effectively on this mass, that force will be upwards. So the spring force that is coming from the left spring will also be k delta. So effectively these two are in parallel. It is as if the system is as if you have two springs like this, right? And this is nothing but springs in parallel. Okay, and we have seen from the force balance also. So effectively 2k delta is the thing, and 2k is the k equivalent. So this k equivalent is 2k, and therefore the natural frequency radians per second is k equivalent by m, and that is nothing but 2k by m. So the answer is C. So just always when you have these combinations of springs, what you have to do is displace a mass by delta and see the effective spring force that is coming. So effective spring force that we got here is 2k delta, and that the value which is beside delta, that is your equivalent k, that is 2k, right? So that is one way of doing it. The other way is try to convert into this. So we have effectively seen that you can convert in this, and this is nothing but, this combination is nothing but spring in parallel, and which is 2k. Okay, so always, I mean, parallel and series, if you have a doubt, the best thing would be, which I suggested, displace a mass by delta and then see the total spring force. The total spring force, if it comes out to be 2k delta, then the effective stiffness is 2k. Okay, and so that is the idea. So the answer is C. Thank you.